the surface of the water. Okay? We want to figure out how deep this submarine is. We're trying to figure out how deep that submarine is, and to help this U.S. Navy destroyer sink the submarine, we're going to throw a torpedo at this submarine, and it's going to destroy that submarine. So let's figure out how. Again, this is your notes, so it doesn't matter how good your drawing is. Just make a basic drawing for your notes. On tomorrow's quiz, I'll probably throw one little real-life problem at you. I mean, it's really the same stuff. Poker. Think of the poker analogy. What did they give us to work with? But what side did they give us? Thank you. Look at, they gave us a hypotenuse, you guys. We know it's a hypotenuse because opposite the 90-degree angle. So it's either going to be the sine or the cosine, because both of those have hypotenuse mentioned in it. Which one do we use? Well, we're trying to figure out the depth of the submarine from the surface of the water. This side, what is this side in comparison to 35? That's going to be the opposite. X would be the opposite. So between the sine and the cosine, I'm picking the sine, because it deals with the opposite and the hypotenuse, the two sides that I'm interested in the problem. And the rest is this simple algebra as we're accustomed to. Here we go. So let's go sine 35. We'll figure out the depth of the submarine.
I know the depth.
Nice. Help me out. Set it up first, though.
X over 400.
Thank you. Opposite over hypotenuse is 400. By? Nice. Let's multiply by 400 on both sides. X then is approximately 400 times the sine of 35. Adiaga, you said you had it? Hit it.
229.4 meters.
Thank you. Thank you for specifying the units. That's awesome. 229.4 meters deep is that submarine. No biggie. You have a real life situation, you figure out what cards they dealt you, and you figure out the ratio you need to use for the situation. It's either sine, cosine, tangent. Question so far? One more example and we're done. But the next one's kind of a doozy. Going once, going twice. By the way, that's the problem of the week. I'll put up later. Number 2 is, here we go. Now, instead of writing out in the paragraph, you can just put C video, because I'm going to post this to the video anyway. You don't feel like writing the paragraph down. If you do, that's your prerogative. But go ahead and draw a simple sketch here of 2 buildings here that are across the street from each other. I'll give you a minute to go and sketch the picture. If you want, on your notes, go and just, instead of, like I said, just put C video, because this paragraph will be on the video on Google Classroom eventually. So if you want to save time for yourself, or if you want to write it down, it's your prerogative. See what's going on here. So 2 buildings are 60 feet apart across the street. All right, so let's see. 60 feet apart. That means I'll put 60 right here. The problem gives me that 60 feet. A person on top of the shorter building finds the angle of elevation. So here's Mr. Mungia again with his cup of coffee on top of this building. Mr. Mungia and all of his adventures with his coffee. He's looking, angle of elevation means I'm looking up, elevating, so it's a 20 degree angle here, my line of sight to the top of the building. And an angle of, they call it an angle of depression. That means I'm looking down. If I look down from my line of sight, this is an angle of depression. That's 35 degrees downward to the bottom of the building. What does Mr. Mugia want to know here? How tall is a taller building? I want to know from here to here. Any ideas of a game plan? I'm right there with my cup of coffee on top of that shorter building. I want to know how big that taller building is. We're obviously going to use trigonometry because that's what I'm teaching. So that's like the big hint right now. The question is, what kind of how am I going to use trigonometry to figure out the height of that building? What do you guys think? So the tangent 35 is y over 60 multiplied by 60 to get y by itself. Y is approximately 60 times the tangent 35. Somebody got a calculator for me? 0.0? Thank you. In this case, 42.0 feet, huh? Are we done? Now what? So all we know, now look at, check this out. What we know at this point is from here to here is 42 feet. One more time. So tangent 35, we solve for y. So this is 42 feet. Tangent 35 equals opposite over, that'd be 42 over 6. Right, so we're done there with the tangent 35. So we know from here to here it's 42, but I want to know the whole dang building.
Tangent 20.
Uh-oh. Uh-oh. So you're going tangent 20 now.
Yeah.
Let's see. So she's using this right triangle now. The one on top, my angle of elevation. Let's see. Tangent of 20. Go ahead, Reyes.
Equals z over 6.
One more over what?
Z
Z
over
over 6.
So you're using from here to here z. So she's throwing another variable in the mix. She's saying from here to here z. This side's opposite of 20. Z over adjacent to 20. Look at this is touching that 60. And let's solve for z now. So multiply by 60. Multiply by 60. This is done. Z is approximately then 21.8 feet. So look at the blue. What's Z? 21.8 feet. So I think we're in a position now to figure out what x is. Since you guys both work together, that'll be me 2 stamps each. Okay. I know the height of the building now. Just add 42 and 21.8 and we're there. So it's like 2 problems in one. So 42 plus 21.8 I want to say is 63.8 if I'm not mistaken. So the height of the building is 63.8 feet. Trigonometry is beautiful. Very nice, very nice. I'm going to put this right here so you guys can copy. So the key was making from here to here y, and we solve for y on the red part. And the second part, Miss Reyes brought in the whole variable of z. So from here to here was z, so she took the tangent of 20, that's in blue. And then she added up y and z, both side lengths, to get the height of the building. So go ahead and copy that down if you haven't done so yet. Garcia, give me one light.